Welcome to interfaces. An interface flips the way we think about types, from what an object is to what an object can do. It's a powerful idea that lets completely unrelated classes share capabilities, and it shows up throughout the AP course. By the end, you'll know exactly how to choose an interface over an abstract class. Let's get into it. All right, lesson objectives. I'll explain, or maybe you can explain what an interface is and why it's like a contract, write an interface and a class that implements it, use an interface as a type for variables and arrays, and decide when an interface is the better choice than an abstract class. These 4 skills round out everything you need for this unit. All right, into the actual lesson itself. Let's meet interfaces with one clean idea. An interface is a contract. It's a list of methods that a class promises to provide without saying how. Think of it as a capability label. Anything labeled comparable promises it can be compared. Anything labeled drawable promises it can be drawn. The interface doesn't care what the class actually is. It only cares what the class can do. That's the big shift from inheritance. Inheritance is about what something is. A dog is an animal. An interface is about what something can do. And totally unrelated classes can share the same capability. We'll see the syntax next, but hold on to that word. Contract. An interface is a promise about behavior. A contract. All right, exciting stuff. The syntax. You declare an interface with the keyword interface instead of class. And inside, you list method headers ending in semicolons with no bodies, because an interface says what, not how. Then a class signs the contract using the keyword implements, and it must provide a real body for every method the interface listed. In the example, the interface declares the method header, and the class that implements it fills in the actual code. The most powerful part, a class can implement several interfaces at once, separated by commas, even though it can only extend one parent class. So interfaces are how Java lets a single class take on many capabilities from many sources. Here's the payoff, and it should feel very familiar. An interface name is a real type you can use for variables, parameters, and arrays, just like a class. So you can have an array declared as the interface type and fill it with objects of completely unrelated classes, as long as each one implements that interface. Then you can loop and call the contracts method on every element, and each object runs its own version through dynamic dispatch. This is polymorphism again, but freed from the inheritance tree. That's so cool. Polymorphism, but without inheritance. You can group objects by what they can do rather than by what they are. That flexibility, treating unrelated types uniformly through a shared capability, is the whole reason why interfaces exist. All right, let's finish by deciding when to use which, because students mix these up constantly. Use an abstract class when your types share a real is-a relationship, and you want to share both common code and state fields with the subclasses. But remember, a class can extend only one parent. Use an interface when you want to define a capability that's unrelated classes can share. And when a class needs to take on several capabilities at once, since a class can implement many interfaces. The quick test, ask is a versus can do. Is a points to an abstract class. Can do, especially across unrelated types or several at once, points to an interface. Keep that one question in your pocket and you'll choose correctly every single time. Ask is a versus can do. Is a versus can do. Is a abstract class, can do interface. Even I get this kind of mixed up, but just hone that and you should be solid. All right, which class compiles? Give it a second and we'll answer it. All right, given interface size, which declaration compiles successfully? Option A claims to implement size but never defines size. A concrete class must implement all interface methods, so A fails. Option C uses extends with an interface. A class implements an interface, extends is for classes, so C fails. Option B implements size and provides a public in-size body. It satisfies the contract and compiles, so the answer is B. Here's what I'm going to reinforce with you guys. Implementing an interface is a promise you must keep by defining every method, and you use implements, not extends. You use implements, do not use extend. All right, let's try this one before we end it off. All right, reasoning check. Playable and drawable are interfaces. Sprite implements both. Which statement is true? Option A is false. A sprite is a playable. It implements it, so it fits a playable reference. Option B is false. Interface requires no shared subclass. That's exactly their advantage. Option D, it's false. A class may implement many interfaces. Option C is true. Implementing both interfaces obligates Sprite to define all methods declared in each. Again, keep saying this, I'll say it again. Interface, contract. Interface, contract. Each interface is a separate promise, and the class must keep every single one of them. All right, key takeaways. An interface is a contract. How many times I've said contract in this, this lesson? You better now remember it on the exam. An interface is a contract listing methods a class promises to provide. A class signs on with implements and must define every method. And a class can implement many interfaces at once. An interface is a real type you can use for variables and arrays, enabling polymorphism across unrelated classes. And remember, the is a versus can do test. Is a versus can do for choosing between an interface and an abstract class. All right, that finishes up the lesson on interfaces. Fantastic work getting through this.